Welcome to People Power Social Club, our daily digital event space ensuring no one feels isolated or alone whilst we spend more time at home.
Welcome everyone to the last episode in season 1 of People Power Social Club. Today we have Dr. Alison Cooke, and she's going to be telling us a bit more about the innovative Wingsail technology and how it can help make our shipping more sustainable.
For the first time, the America's Cup is being held close enough to shore to be a spectator sport. And there's definitely something to see. The new boats are faster than ever. These boats, called AC-72s, are 72-foot-long wing-sailed catamaran. As they pick up speed, the crafts lift out of the water on top of small carbon fiber hydrofoils and accelerate to speeds as fast as 50 miles per hour. That's more than twice as fast as the boats that competed at the last America's Cup in Spain, and it's almost 4 times as fast as traditional monohull yachts that have participated in the race for over a century. When you have 1/4 of the time to make the right decision that you had in years past, there's an incredible pressure on the crew to get everything right, because consequences from making a mistake in these boats can be catastrophic. Higher speeds have meant an increased level of danger, as well as another barrier to entry. Designing and racing these boats is really expensive. The cost of an America's Cup campaign has crept up to as much as $100 million. A lot of potential participants who were enthusiastic about it early on couldn't find the funds to be competitive. The few teams who are participating are part of the evolution of a 162-year-old sailing event that has now become an extreme sport.
Welcome to everybody to my talk on Wingsails and sustainable shipping. This is the 4th talk I've given for People Power, and I'm really pleased to sort of finish on this one, because Wingsails are not just stating what the challenges are and what the problems we might have to face with climate change and with sustainable energy, which is some of the themes of my previous talks, but this one gives an idea for a solution to some of the challenges we might face, and therefore is a little bit is a good positive way to move forward in these talks. So I've just shown a clip about the America's Cup, which was in 2013, and the advent of Wingsails in the America's Cup revolutionized the actual event, and has taken the America's Cup and speeds in the America's Cup to a whole nother level. But as it says on that title slide, what do wind turbines and the America's Cup have in common? And for those of us in the geeky academic world, the main subject area we're talking about there is aerodynamics. So some of the aerodynamics, I'm an engineer, for those of you who don't know already, and some of the aerodynamics theories you would use for wind turbines, you would also use for America's Cup. And so the whole area of Wingsails I got into when I was at Cambridge University, and I was working in the field of aerodynamics. So just a shout out to People Power. So thanks very much to People Power for inviting me today, and also for recording these talks for YouTube so that people can enjoy them and hopefully be educated in the future in the world of sustainability. So I'm very much in line with the People Power strapline there, powering sustainable change. And if there is a product which is talking about powering sustainable change, then the Wingsail is one of those products. And you may remember, so some of the previous talks you can find on YouTube through the People Power link, or just search for it. I talked about the fact that I do quite a few of these talks on cruise ships. And in 2016, I was on the Queen Mary 2 talking about sustainable energy and climate change and what was happening globally to the whole area of reduction of emissions. And of course, for the Queen Mary 2 at the time, it was a difficult message to hear, because shipping has always been a very difficult nut to crack in terms of reduction of emissions. And although I know the CEO of Cunard that owns Queen Mary 2 was on the ship, and I was the keynote speaker for that voyage from New York to Southampton, And I don't think it was a very easy message to hear. And when I was asked the question, well, what does the shipping have to do? I was actually saying that, well, they're going to have to find alternative technologies to reduce their emissions because it will be required of them in the future. And lo and behold, about 9 months later, in April 2017, the International Maritime Organization brought in some far more stringent regulations internationally about what shipping can or can't emit. So the Queen Mary 2 would be, I would imagine, would be now looking to modify and remaster the ship to actually make sure they can abide by those regulations. As you may have heard from my previous talks, I'm an engineer. From 2008 to 2018, I was a fellow of the Institution of Mechanical Engineers, which is one of the highest memberships in the Institution of Mechanical Engineers. And I have a background in engineering at Cambridge University and so on. But more about that if you want it online. So what am I going to go through with you today? I'm going to introduce the idea and the concept of a wing cell. If you haven't come across it, not many people have, but that's what I normally find. So I'll introduce the concept of a wing cell. I'll describe some of the history because people seem to think that this is a new concept. I'll just quickly touch on some of the history and how that appertains to what's going on at the moment in the world of wing cells and shipping. I'll very briefly present one page of aerodynamic analysis. I mean, obviously you could spend a whole hour talking about the aerodynamic analysis of a wing cell. And although I know some of you are quite techie, because this is going on YouTube and we want to reach a wider audience, I won't spend too long on it, but I'll give you the basic aerodynamic features which makes it a very unique product. And then I'll consider, okay, wing cell applications historically, but also more recently, what's in it at the moment for wing cells. So that's the plan. And here we have a wing cell. So I took this picture at Portsmouth Harbour, you may recognize it, in about 2001, 2002, when wing cells could be seen on recreational yachts. And so you'll see this is a trimaran hull, and it's a leisure craft. And the wing cell is essentially this particular wing cell, which was called the Walker wing cell. And it is literally an aircraft wing vertically set into a hull. Okay, so it's an aircraft wing vertically set into a trimaran hull. So what that means is if you're taking a flight, on an airplane, you will know that the aircraft wing is horizontal, the air will blow over the wing, and that will give a lift which will lift the plane off the runway and hopefully safely take you onto your destination. Maybe not as many flights you're doing these days if you're into sustainability, but that's essentially how an aircraft wing works. And although I'm sort of a little bit more ambivalent about flights these days for climate change reasons, I have to take my hat off to aeroplanes because that's one of the reasons that got me into engineering in the first place. It is an incredible engineering feat that you can get an aeroplane off and into the air just by having a wing. I just found it fascinating. And lo and behold, I ended up in aerodynamics for my research. So then if you take that concept of how you lift a plane off the ground, lift vertically, if you vertically set the aeroplane wing into a hull, the air will flow. In this instance, the air would be flowing on an aeroplane wing. It would be flowing left to right, and so the lateral force in an airplane, that's called the lift. But the lateral force you'd get for this ship would be into and out of the computer screen for you. So you get a lateral force in the same way that you would get a lateral force on a canvas sail of a conventional yacht. And that is what then propels your boat through the water. Okay, so that is what we're talking about. We're not talking about this. This is basically a prototype wing sail. So I have actually been to conferences with my colleagues who do aerodynamics of kite ships. Sorry, it's not a wing sail, it's a kite ship. And this is basically, as it says on the tin, it's a kite which can actually pull ships along. And these have been trialed on bigger commercial vessels as well. But today we're going to be talking about the wing cell, which is, think of it as the aircraft wing vertically set into the hull. Okay. And here are some pictures. Fortunately, we happen to have a family holiday in the San Francisco Bay Area. You may recognize Alcatraz about 7 years ago, and we were lucky enough to see some of the America's Cup, and it's absolutely phenomenal. In the same way that I get excited about airplanes, it's phenomenal to see these boats and what speeds they get up to. And if you came a bit earlier, you would have been able to see my clip, which is a video clip of that America's Cup race, and how they lift off off their hull and rise up above the water and go up to speeds of about 50 miles per hour, which is about twice the speed of a conventional yacht that you would be used to in America's Cup. So this is an actual rigid sail. It may look like a soft sail, but this is a rigid wing sail. So this is an alternative model of the wing sail I showed you earlier. That's another view of it, and you can see it lifting off onto what's called these hydrofoils, and that reduces the hydrodynamic drag on the hull very markedly. But they have to get up to certain speeds before it lifts off. I could do another talk on hydrofoils and how they work, but you get faster speeds through the water because your hydrodynamic drag is much lower. So as I promised you, I would just give you one slide on the aerodynamic data. And this one slide essentially gives you why the Walker wing cell, or a wing cell concept, is far more powerful and hence used in races like the America's Cup. So CL max and max L over D, those are, for us aerodynamicists, those are normal ways we would describe an aerodynamic product. CL stands for the lift coefficient, and the lift coefficient in the instance of Wingsails here, 2.6, compared to a soft jib that you would see a canvas sail, you can see it's much higher. And what this means is that for the same sort of size sail or wing, and for the same sort of conditions of the air and speeds that you're traveling at, you will get far more lift than a conventional soft jib or canvas sail. So 2.6 means for the same sort of shape of wing and for the same speeds, you will get far more lift than the conventional sail if you use a wing sail. And that means, of course, that you'll go faster. So it's just a simple, translation to more lift, more lateral force on the boat, faster movement, which is why the America's Cup yachts have actually blown records out of the water. And maximum L over D is another thing we would look at, which is what is your lateral force over the drag on the boat. And again, you can see that for the Walker wing cell, which was set in a trimaran hull, it was twice as big as the soft equivalent jibs on a trimaran soft canvas sail. So you'll get the downsides of that, of course, which is why Walker wing cells did not take off in the sector of leisure yachting, is because when you're trying to maneuver these big boats in a marina, not necessarily a small marina, you've got, for a very small wind, you've got quite high forces on the sail, whereas for a soft canvas you can let them flutter, and you can let the sail out, and you will find it much easier to maneuver safely with a soft jib and a soft sail than you will with a wing sail because of the high lateral forces. Okay, so I could talk some more about that if you want to, but I thought the history would be quite interesting. I'm keeping an eye on my time. We've got 5 more minutes. It's had a potted history. Like I said, these have been around since I was an undergraduate at Cambridge, actually, pre-1981. I went up to Cambridge in 1981. So pre-1981, they were doing investigative aerodynamics on wing cells. Really, their origins were because they wanted to look at them as an alternative, energy efficient option for commercial shipping. So in other words, energy efficient, but as the decades have gone on, of course, it's great for emissions reduction. The company that had this prototype, the Walker Wingsail prototype, was launched in 1981. Fantastically, had 6,500 individual shareholders, not big companies, all wanting to invest in and have the trust in this technology over 17 years. And this was the first prototype, and this was the Walker family having, when the World Trade Center, the Twin Towers were still up then, and they basically had just sailed across the Atlantic through a hurricane into Manhattan Harbor, and proved that the concept worked. So the concept was first proved by the Walker family on a trimaran hull before it was put on a commercial ship. And that was in about the mid-1980s. In 1986, it was trialled on a merchant vessel, the MV Ashington, which sailed out of London towards Scandinavia for its first trial pilot on the back of the commercial ship. You'll see a similar style of product concept as what's on top of the trimaran hull, which has been mounted on the back of this merchant vessel. Now, sadly, for that trial from 1986 to 1988, they only experienced with the Wingsail thrust equivalent to 8% of normal engine load. And so that wasn't good enough. That one trial wasn't good enough financially. So the project was shelved. However, when you dug down, I came to this in the mid 1990s and early noughties. When you dug down into that report, you actually found that because you were sailing east, you only had wind that was available, usable wind, for 30% of the passage time. So that 8% was of the whole voyage, but actually only 30% of the time was the wind available. There were lower than average wind speeds during that trial. And the Wingsail, because it was the first time it'd been put on a commercial ship, had significant maintenance downtime. So actually, you can dig beneath that and think, well, actually 8% of normal engine load is not because the product necessarily was not working, but because of all these peripheral sort of scenarios. And so therefore, when you fast forward to 1996, where in Japan they had similar Wingsail trials with a different type of Wingsail, they actually published some papers and reports on it, which showed that they got 30 to 40% of fuel cost savings for their ship. But again, the project was shelved due to high maintenance costs because they were trying to improve the concept, and also the oil prices were falling. And so the shipping companies were saying, well, it's more financially viable for us to just use oil. So they had to diversify, and they went very strongly diversifying into recreational yachts. And I'll fast forward this bit. So this is sailing through Gale Force 7 on the Solent, just south of Portsmouth, when other traditional, conventional, soft canvas sails, all the ships, there were Maydays. We heard Maydays while we were sailing along in this. We were felt perfectly safe in our Wingsail yacht when other ships were making for shore, because you feel like you're just in a racing car. You know, you're basically enclosed it's like a cockpit of an aeroplane in a way, the way it looks, the way it drives, like cross between a Formula One racing car and an airplane, like I say. However, that meant, in our opinion, it meant that the company was not successful in the recreational yacht market, and so the company failed in 1998. Sorry, Walker Wingsail's company failed, but the shareholders, 600 of them, you remember 6,500 invested in the first company, 600 of them still believed in that product. And so they basically formed a new company, Wingtech, which 1 year later also went into liquidation. And then I was brought in by one of the major shareholders to assess whether it was to do with the product failing or whether it was to do with market conditions or management issues or what was going wrong. So I'll fast forward all that stuff, which is the outcome. The most important thing to tell you is after a year working with that shareholder and working with the two companies that had gone into liquidation, my summary was that there was nothing wrong with the product. It was just more to do with the fact that the market was not right at that time because oil prices were too low, and so shipping companies were just not interested. And also there were management issues within the company two companies, which I won't go into, but they were not conducive to being successful. So fast forward, it was used by disabled sailors who sailed around Britain in a wheelchair. So it's very good for wheelchair use because the wheelchairs can get around the hull. But fast forward to what's happening now. So summarizing what I've just said about the history, the product is fine. It's been proven a number of times. However, the companies keep failing. Why is that? So 2007, it was rebuilt and modernized as a recreational vessel, took the voyage around with the disabled sailor. And in 2012, a new company was formed, particularly focusing again on commercial shipping, because in 2012, of course, the whole climate change agenda had been ramped up by the United Nations and by the world governments, national governments. And so it was the bunker costs for fuel for commercial shipping in 2012 were starting to escalate, something like 6 times what they were in the previous decade. So a new company was formed thinking, finally, we will be able to get commercial shipping companies to actually pay attention to alternative propulsion methods. However, like I said, right at the start of this talk, it wasn't until 2017 that the International Maritime Organization brought in new regulations on emissions from ships. And so sadly, the company Ocean Foil also went into liquidation last year. So it's seen some highly successful outcomes for America's Cup since the other companies were formed. But unfortunately, commercially, it's still not being taken up in terms of shipping and to reduce the emissions for commercial shipping worldwide. So what about the future? Just finishing off, is it going to be from this slide in the 1980s, where they proved that you could sail across the Atlantic in a hurricane? Is it going to be just left languishing in the area of recreational vessels? Or will it be successfully implemented onto commercial ships? Will you see it on the Queen Mary too? You know, with coronavirus, who knows what's going to happen to the cruising sector in the near future and beyond. But I always have a nice picture of my children because it reminds me it's our children's future we are playing with, not just our own. And sustainability is all about living now so that future generations can actually live the same quality of life that we enjoy now. So for the benefit of our future generations, where will Wingsails be? Who knows? And I very much hope that it will be part of our sustainable future in the world of shipping.
Stay safe, stay busy, and tell us a cool story next time we see you.